So here is an update on the big drone. So as you can see, it's all standing up. It's kind of hard to even film it anymore since it's getting so big. So let me kind of focus you on a couple different things here. So the last video, I was showing you what I had done with these pieces here, and down here had made the feet. So the feet were pretty cool. That was just a quick little, not a quick little, but an addition. I just had to have it look kind of cool. Milled out entirely, done in Fusion 360, and et cetera, so on, right? So we've got those attached, and let's see. So now the wires are all installed. I chose to go with these types of banana connectors right here so that things could be more modular. That's, as you can see, loose. But the idea being that with this 80-20 material here, that everything on here can easily be removed, replaced, or whatever. So the motor's down here. You'll just disconnect here, shown this in the last video. This whole unit will just slide away. And the same thing with pretty much all of these components through here. The arms themselves, it's a little bit more tricky, but it's doable. This piece, if you follow this and look at this, is just like the X going through, discount these arms, that will all stay together. And I can take these fasteners out inside here, and this whole arm will then just slide right out. And we did that for transport's sake, for ease of transport. It's not like it's snapped together, so it's going to take like half an hour or so to set it up in the field somewhere. But that's kind of the idea with this, is that you would be creating this for agricultural use or construction site use, and you don't just roll up and kick the thing out of the back of your truck and move on. You're going to break it out. You're going to have all these components separated, and you're going to build and put together the drone that you need for the application. So you might have multiple different lengths of arms, and today we're lifting 8x4 sheets of plywood, and so then somewhere down here you'll have the plywood and say, okay, well, we're going to have a little bit longer arm, and okay, we'll grab that and we'll plug it in. And then also that then brings me to the shock system here. This can be adjusted for the load that you're carrying. And so then again, the idea is, we need something, heavy duty. Well, then you can prop it up more. It's a little bit lighter. If you bend this out, if you bend this arm here out there like that, then it's going to essentially defeat the shock more. So then you'll be able to, have kind of a softer ride. Incidentally, we're kind of calling this position right now sort of service mode. So you see how far the legs are brought in like this? That's not the way it's going to fly. So these legs right here, what they're going to do is they're going to loosen these up here and kick the legs way out. So this angle right here is going to be dramatically more reduced. And that's to create a lot more mechanical advantage on this lever arm here, the leg, so that we can knock back that shock a little bit. That's a 450-pound shock, and the reason for that is because that was the best one I could find. Everything on Amazon was an inky-dinky tiny, like RC shock or a big full-size, car shock. And so this one is for a mini bike or a go-kart, okay? So 450 pounds on each leg here for a vehicle that's going to lift, around 200 pounds. And so that's not very good. So again, like I'm saying, we get long lever arms here, and we knock these things out quite a bit. And so of course, if we knock them way out, angled like this, then the shock would be kind of angled back in there. It's gonna be really soft. It's gonna be really squishy. But if you've got a light load, maybe that's okay, right? And then you could adjust as you see fit to help carry. If you needed to, you could always add another shock. All right, enough of that. What else has got to go on here? This here is pretty rigid, as far as like if I tried to move this, we put kind of a wrench on here and kind of twisted it. It seems pretty strong, but when I was doing testing, we've got this thing, spinning and moving. Just the torque from the motor without the propeller causes this. You can see a noticeable shake in this. And so I can see things to come, which I'm sure you can too. Looking at this, it's going to wiggle a lot. So we're going to move these arms in, and I'll make another bracket that fits over the top of this 80-20 and shoot it over that direction and tie into here. And so we'll have kind of just a big square going around here to tighten all that up. The other thing is right now, if I wiggle, 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 these legs are super wiggly right now. They're not really tightened up, and it's not the best type of system right here. This should have been more like a triangle right here coming down, more like your typical swing arm on a motorcycle, but it was kind of a timing issue and cost. So we're going to go with it right now, and also kind of theorizing that when you're landing, you're probably not, bam, you know, coming in for a big crazy crash landing. You're going to hopefully land relatively soft. Again, the arms will be out, the legs will be out a little bit longer. And so when you come down, it should give you the ability to where even if you got like 2 foot off the ground, a foot off the ground, it kind of, you know, dropped kind of harshly. Yeah, it'll wiggle a little bit, but maybe it won't fall apart. So that's what we're hoping. The thing that might have to be that I could see being a problem is it does land like this and it kind of herks and jerks. And if you're still armed on the quad, then the PID system will think that some crazy crap is happening. And I could see that being where it wants to flip-flop. So I have to kind of watch for that. Incidentally, that brings me to this then. I don't think I mentioned this in any of the other videos. I'm going to run Betaflight on this. So this is going to be just the same right now. You see, this is just a DYS flight control board right here. So this is, it's kind of a reason for that. You know, I wanted to see if we could build one of these the same way that we do a big, a small racing drone. And so that's why we're using that flight controller. The one we'll, really use, we're really going to use this board here for test hovering and see how that goes. But Lumineer just came out with a flight control board that does 8 motors, 2 cameras, a couple other special features. So we're going to go to that. Oh, and also the other main reason is you could reflash it from Betaflight over to iNav, which will allow you to do GPS waypoint mapping. So that's kind of in the future. But for just quick, fast, getting it up and running and flying and standing here with a controller and voop, 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 making it go yourself, that's why we're doing it. Okay. So again, here's the ESCs. These are 180 amp ESCs from T-Motor. The motors are T-Motor as well. A camera for no other reason than it's their typical VTX AKK. Nothing spectacular, using FrSky equipment. So it's basically just a really big FPV drone at this point in time, your typical one with big parts. Well, I think that's all I have to tell you about this so far. I am recovering a little bit, of course, about all the material I've talked about so far, mainly because I don't think I've had a chance for a while to get out here and actually just talk kind of live like this about it. I really don't like doing the overdubby thing because it just doesn't seem like it's live enough, I guess. Okay, so let me show you. So here's what's going on next. So what we're going to do from here on out, probably even starting tomorrow, we're going to put the propellers on it. And now these beams right here, I do have to get that beam across there, but we're going to try to test it. I think I'm pretty certain we're going to test it even without that, just to see, because you can always disarm, right? We have to take this and we're going to tether it down. So this is not like we're going to sit here and try to hover it right here. But what I want to do is drop the legs out like I've been talking about. And then we're going to, we've got some, I think it's about 14,000 pound paracord, and we're going to hook it onto here, and then we'll bring the cord out something like over to here and anchor it into the floor. And so we're going to nail this thing down into the ground, into the concrete, and we're going to hover it here in the building. Like we're just going to go for like 1 foot off the ground just to see how it works, and then decide what to do from there. This hasn't been certified. We don't have a 333 exemption or anything like that yet on that. So we're not going for any kind of field flying. We do have some places we might take it to prior to that, just to do again like a little bit more than a foot hover test, but we'll see how that goes down the road. Okay, well, I guess that is it for this update. You can see it's pretty big. I'm backing up the room here, and here I'll hold this way up here. Try to get some some scale on that. It's definitely a monster, but it is not really that heavy. It I can pick it up, the half of it here with one hand. I'm thinking it's about 80 pounds actually so far, for not so bad. So it could still get up 100 pounds or more of a load on here. One probably big thing that I didn't mention about this is that it is all functioning right now. So I've been saying, yeah, we're going to do some hover tests and all that. What I didn't mention since the previous video is we did get the flight control board hooked back up. We had some problems with the motors acting screwy, and it turned out that inside of this wire mess in here, one of them did just get screwbally to the wrong, it was soldered on the wrong pad. So that was great. Quick, easy fix. Rearmed everything, spun it on up. All the motors move as they're supposed to. Grab the flight control board inside there, give it a little tilt, the other motors go, little tilt, the other motors go back and forth. And so the PID loop and all the angle mode balancing is in effect and it's working. I can tell though that these motors with the low KV on them, big power motors, they don't quite have the reaction of the fast ones. So I'm a little bit concerned with that. I think this is going to be a little lopey-dopey in the air. So we'll have to figure that out, and that might be a whole nother revision for this. So anyway, that is the whole update for the big heavy lift drone project. I think tomorrow is going to be the day that we're going to get this thing anchored down to the floor, and then probably this weekend when there's nobody around in the shop, then we're going to try the test hover, just for like maybe about a foot off the ground or so, just to see how it goes. And of course I will video that and keep you up to date.